recording on this screen. Okay, so back to this video, part 2 of this lesson. I have 25 minutes with you. And the last question, someone please. Actually, I should be able to figure it out. So height was now, oh, no. I have to reset it. So this entire thing was, yeah, t to the power 4 minus 59 t cubed plus 1190 t squared minus 9400 t equals 24. So minus plus 24000 equals a 0. So yes, by integral zero theorem, you would have to test every single number that will be a factor of 24,000. That is rude. Let me tell you what the numbers are with the promise that I won't give you something this big on a test because it's a waste of your time. I want to see what you can do, not go through a maze. Okay? I'm not like North Toronto. Did you know? On a quiz, like a 10-minute quiz, I remember this was like 5 years ago. It's a teacher that I know. He put a quiz on and made the number have like 20 different factors. And it was like the largest number. So they would have to go through 19 numbers before getting to the final number that works. Huh? No. The only way teachers can be fired is if they do something not nice. Okay. And okay. Not nice in different ways. Anyways. Here, I'm going to give you the numbers. Okay. One of the numbers that works is going to be 5. So let's test it. If the t value equals a 5, that's 5 to the power of 4. I'm going to need some help with this, okay? 5 to the power of 4, 5 is 625. But I'm going to need help for this. What is 125 times 59? That's negative 7,375 plus 29,750 minus, has to be 5, 47,000 plus 24,000. And I believe it should, yes. Perfect, it does equal 0, yay. Okay, so again, I'm giving you these numbers just to show you that integral 0, it's going to work. And so you're going to take this number, let us plug in these coefficients in synthetic division and make our lives a little bit easier. We've got the root is 5, and we have 1, negative 59, positive 1190, negative 9400, sorry, and positive 24,000. Drop it down, 5. Negative 54, multiply. Yep, negative 270. Add that, 920. Multiply it, 4600. And then multiply it, and we get there. Where'd you get the 5? Oh no, yeah, I'm just giving you the number, right? The factor is x minus 5 is going to work. I just gave it to you because I don't want to waste your time with it. I want to show you that it works. From there, so this is my new equation with the remainder of 0. So I need some space, so I'm gonna bring this down. In fact, am I able to copy and paste this on a whiteboard? That would be amazing. Yo, Zoom, I will be your fan forever if I can actually copy and paste there. No, I cannot. That makes me sad. I am no longer a fan. Okay, Can someone tell me what the function was? So the height formula can be rewritten as x minus 5 times, sorry, t minus 5, sorry. So t to the power of 3. Okay. 48,000. Okay. I'm going to give you another number, the next number, 10. This is going to also be a factor. So, but I'm not going to use the entire thing. I only need to use this because that is what I'm trying to factor. T minus 5 is done. I could set it aside. So synthetic, 1, negative 54, positive 920, minus 4,800 is going to work with a 10. Negative 44, 440, that's a 480 times 10, positive 480, perfect. Because the question is asking when will the height be, when will this roller coaster be above 24 meters, right? So right now I set it up so that I can find when will it equal 24 meters. Oh, again, integral zero theorem. I looked at the final term of the polynomial, and I would have to test every single number that can divide 4,800. But I'm telling you that 10 will work. I'm going to give you numbers where you can test it without feeling scared. I'm not going to give you such a big number that you have to test like 100 different ones before you find a factor. Okay. So we have, so if that's the case, my height will be equal to 24 meters at this point. So that's going to equal a 0, basically. At nope, this is factored. 1, negative 44, 480. The negative 10 is already, sorry, t minus 10 is already divided out. Yes. Yes.
So basically just for this, what we're doing is we're getting the number of they're going to look for seconds. It doesn't equal 0, sometimes the exact like the highest possible number, but it still equals 0, and that would be the answer.
No. Doesn't have to be the highest.
But are we looking for how long it stayed
Again, read what I just wrote. This equation that I set up very early on in this question, I set it up so that I figure out at what time does it equal 24 meters, right? So it's some big formula equals 24, because I don't want to solve a math question with 24 on the side. I brought it to the other side and turned it into a 0. I manipulated. I turned the 24 into a situation where I can use the math skills I have learned in the past. I made one side equal to a 0. So if I solve everything and figure out what t values make this equal a 0, what I've actually figured out is what t values make the height 24.
And is it only asking for 1?
No, look at the question. Don't ask me. Look at the question. What is it asking for? Over 24. So I'm going to figure out when it's 24, sketch the graph, and I could say, oh, at this point, it's over. You'll see. So I have a quadratic now. And can we do this by mental math? Two numbers that multiply to 480, but add to negative 22. Eh? 20 and 24. Perfect. Okay, so I'm going to sketch this out. 5, 10, 20, 24. The lead coefficient is positive, so it's going to probably be something like, wait, is it positive? Oh, no, no, no. In the very beginning, we divided it out. It was actually negative, wasn't it? It was a negative 0.001. So, no, no, no. The graph should be something like that.
So are we thinking not going on the ground?
No, this isn't. This doesn't necessarily represent underground. When this function is above 0, or sorry, when this function equals 0, is actually like saying this function hits 24. Remember in the original, the function equaled 24. So I want to know when it equals 24, which is right there.
So it equals 24 at 4.
But I subtracted both sides to make that dotted line go back to the 0 axis. Think about it that way. I did a vertical shift down.
So we're manipulating the roller coaster to just find that.
I'm manipulating to pretend the roller coaster has shifted down 24 units so that I can use the x-axis instead of this silly imaginary 24 line.
That's why we're saying okay, 0, just because we could get 0.
Yes, I can actually use the math algebraically. So between 5 seconds and 10 seconds, I'm above 0. And between 20 and 24 seconds, I am above 0. That, therefore, will be the exact same intervals that's going to be above 24. So the final thing would be the car is above 24 meters between 5 and 10 seconds and 20 to 24 seconds. Yes. Yes. In total, I will be above 24 meters for 9 seconds of the entire ride. Yes. This one? Absolutely. Yeah. If you didn't want to factor, if you remember in grade 10 and 11, they said, if you don't want to do this, the foolproof way, the way that you can do it without factoring is to use quadratic formula. Yes. If you do the plus, you'll probably get one of these numbers. If you do the minus, you get the other number. So I'm thinking the plus minus is probably a value of 2 because the spread is 4. It's like plus minus 2. Yes. Yes. You make your life easy. Well, you're dividing both sides by negative, which means a 0 is also divided by negative 0.001. So originally the graph was a negative. That's why I know it's upside down. But when I was manipulating, when I was algebraically solving, dividing both sides makes it a lot easier for us. So yes, that's why we did it. If -5 is divisible, is a factor for every single coefficient, absolutely. You could do anything you want because the other side of the equal sign is a 0. You can multiply by 1 billion. You can divide by 1,000,000,000, but that 0 still doesn't change. So
Is that just negative or does it work?
you can work with the positive, right? But you want that first term to be just a coefficient of 1. It makes your life easy, right? It's all about manipulation. Okay. I only have 10 minutes with you, and chances are I might have to let you go earlier because we're in the 3rd floor. 2.6 is literally this, like not word questions, but the idea of like when is it above or when is it below a certain number, using an inequality. But instead of me checking, hey, when is it equal to a 0, right? Or when is it whatever, you can turn this into an inequality and say, when is it going to be greater than, when is it going to be greater than a 0? In other words, math doesn't change. How you talk about it in your therefore statement simply changes. That's all. I wanted to give this to you, but it seems like tomorrow is when I will have to do it. Know that tomorrow then, page chapter 2.6 is just one piece of paper where I go through other examples with you. I will also have 2.4. Where is my 2.4?
2.5.
Oh, we're not doing 2.5. It's basically learn how to use technology. So yeah.
2.4, right?
Yeah. So tomorrow, I will quickly finish this off along with what question was it that I asked you to remind me of? Number 6. The volume one. In the textbook. You guys forgot already? What question was it that I said we'd start tomorrow with? Okay, you know what? I'm going to write this down. Let me write this down. What question?
Yeah.
Question, page 92, number 6. What's it? What's it? Oh, 22.6. Extension to this. 2.4. This is another style of questions that you might see, you probably will see on the test. It's nothing hard, and it's actually something we've done already in chapter 1, but I want to lay it out like solidly and chisel it in stone so you know what to do without feeling like it's some kind of scary question. That's all. The rest of tomorrow we'll be studying, so I expect a lot of people to ask me questions Friday morning. The first hour will be spent review as well, so you can use me for tutorial. And then the last hour, so 15 minutes plus 25 minutes, is going to be the mini test. Or not mini test, it's going to be 15 test. Yes. Yes. So start working on it if you haven't already. Anyone else?